Welcome anybody. Okay, this is going to be a follow-along video. I'm going to follow along a video that's in the description by Professor Hank Stalick. Hopefully I'm pronounced his name properly. I'll just refer to him as the professor from here on out. So, just in order to do this properly, to do a follow-along, you have to have two YouTube windows open. You run the professor's video to a point, and then you play my video to a point. And what I'm going to attempt to do is produce the same code results that he's producing, but in assembly, while he's using C. Or C++, sorry. So what I want you to first do is click on his video in the description and play it to the point in time 8 minutes and 17 seconds. And then when you get to that point, freeze the screen and then come back to this video, and what I'll attempt to do is produce the same thing he has on his screen. So at this time, what you need to do is play his video to the point of 8 minutes and 17 seconds, and then come back to this video. Okay, so you see that he has 8675 is an array. So what I'm going to do, well, I already have some code here from a previous video. Let's just take a look at what we have so far. It was a video that is about showing that I can send an array into a function. And the point is that when the array comes in the function, it has properties that go with it. And it becomes a pointer. The array actually becomes a pointer because it's passed by reference. But it still retains its quantity and quantity used properties, which is, you can think of the length of an array is actually split into two different values. The length of the memory that you're using and then total length of memory available. So there's actually the potential for growing an array up to a point. So it's a little different, but it's not worse than or better. So what I'm going to do is I'm going to initialize my array with 8, 6, 7, 5. And the fact that I have 5 elements but only 4 elements defined means that I'll have, well, let's run that and just see what we got here. So you see that it doesn't print any elements out, but it shows that the quantity property is 5, and the quantity used is 4. So that's an indicator that you have 4 elements in your array, but the buffer actually has enough room for one more element that we're currently not using. So we need to make a function called print. That's what I'm going to do right now. Oops, let the fingers go too fast. Print. And I'm going to pass into it a dd with properties named, I'll just do his array again. Okay. Now, this code I'm going to write is actually not nearly as simple looking as the professor's code written in C. Sometimes that's the joys of assembly. What I'm going to do is I'm going to declare a variable called current address. And then I'm going to declare a variable called too far address. The idea is that my loop that I want to set up is going to go from an address to an address. There's more than one way to skin a cat, obviously, so it doesn't have to be done this way, but it's just the way I'm going to do it today. What I'm going to start out is I'm actually going to add an extra print statement. Just make this more visible, more readable. maybe more understandable. So when it prints out, it's going to have that in front of it. So the first thing to do is figure out my current address, which is the base address of the array. So the address pointed at is going to be the address of the array, because his array is actually a pointer when it comes through the function. Now, I want to calculate the too-far address. And I may not do it the easiest here, but this is what I have. I'm going to use the RX register for some math. And I'm going to put in quantity used as my first variable. So the quantity used, that's going to be 4. And what I want to do is I want to multiply 4 times did I say 4? Quantity used, yeah, it is 4. 4 times 4, because there's 4 bytes per element. And there's a way to multiply, but there's also in assembly a shortcut way to multiply with a shift left of the bits, 2 bits. It's kind of a quick multiply. Multiply by 4. So now I have a number of the quantity used times 4. Now I want to add that, add RX to the current address, which is your base address. And that will represent the too-far address, the address that's out of bounds. And I want to move into the too-far address my calculated value in the RX register. Okay. Ooh. Excuse me. Okay, so now I'm going to set up a do while loop. Oops. And when I do this indentation here, this is kind of going to, it's a required indentation. It's part of the loop. I don't want the loop to exit or execute if there's no elements. So I don't want it to execute one time. I want it to jump out if there's no elements. So let's do a compare of the too-far address with the current address. What that is it's actually subtraction. It doesn't save the answer anywhere. But it knows if the answer was greater than 0, less than 0, equal to 0, and stuff like that. And the next jump will be a jump based on that answer. So we want to jump out of the loop if the too-far address is less than or equal to the current address. So JLE is going to be our jump instruction. Now what I'm going to do here is, down here, okay, I know I'm going to jump a little bit because sometimes in programming you just don't go line by line unless you've got it pre-written once and you're writing it off the screen, which is what I'm doing. I've already pre-written this. But when you're really programming, you don't go line by line. So I'm going to try to do this, how I did it originally. So the first idea is, what do I want to print? I want to print a space, and I want to print a value. Now, my console prints don't have a way to print a DD. I don't have an overloading built for that. I should add that. I just only have DQs, so that's kind of a little handicap. I need a value which could be a register. Let's use a register. RAX. Yeah, we'll just do it a little different. Now let's move into EAX because our actual element is 4 bytes. EAX is 4 bytes. The contents at the current address. Now my paranoia kicks in and I think to myself, what if the upper part of the register is not zeroed out? I'm not sure if Intel will zero that out for you, to tell you the truth. So this is a step that I do a lot to make sure the register is zeroed out. And it may not be needed because maybe it zeroes it out. I don't remember it this time. So there's the truth. So that should do it. We're going to put the value at the current address in the EAX, forcing it to 4 bytes. And we're going to print out the full RX register, knowing the top half of the register is zeroed out. Sounds good. Now we have a loop incrementer, which our loop incrementer is actually the current address. We're going to add 4 to it, pushing us to the next location. Now, here's going to be a little confusing. I go back 2 indents, and I'm lined up with the JLE. I go back 2 more indents, and I'm lined up with the do loop. I do a jump there. So this jump will be an automatic always jump up to this line, based on my indentation rules. This line will compare the too far address with the current address. As if the answer is ever less than or equal to 0, then it jumps out of all the way down to here, which is out of the loop. May seem odd, but that's how it works. I'm going to do a write at the end. This is another module I have that has some constants defined in its data block. And I got one called CRLF. And it's basically just going to make the line wrap around and, for a new line. So is that going to work? I'm not sure, to tell you the truth. So let's go up here to main. And let's invoke print of my array, and let's create it. Let's run it. By golly, it did work. So we have now the ability to print an array, although the code looked way more complicated than what it was written in C. Truth hurts. Hey, it is assembly, right? And but we have it. There's what a typical equivalent in assembly would look like. And obviously there's more ways to skin a cat, and there's different varieties how to write that. So is it the best? I don't know. There it is. That's what I have. Okay. So now we need to know the next part of this video. I'm going to watch that right now and let you know where you can stop at. Okay, so I watched the video up to the point of, I believe it's 10 minutes and 34 seconds. So what I want you to do at this time, is stop this video and watch his video to 10 minutes 34 seconds. And then come back. Okay. Well, if you're back, you see that he wrote out a function called zeroOutArray. I'm going to attempt to do the same thing. So I'm going to go up here, function, zero out array. And it's going to be the same DD with properties named his array. And it turns out I can use a lot of this code here to zero an array out. I'm going to copy it. And let's see here. Okay, so a few things I do want to change here. The fact that we're not going to be running any internal functions, console.code.write, take that out, and take that out. It kind of changes things a little bit. For example, I can change this current address. It doesn't have to be a variable in the stack. I can change it to be a register x8, which I know in my head that means that will be R10. It's just how that works internally. Register x8. So those don't need to be stack values anymore. They can be registers because we're not calling the console function and have the fear of having our registers overwritten. So now we're going to move. We're going to start out the same. We're going to move into current address, the address pointed at by the array. And then we're going to be using the quantity used variable again in RAX. We're going to multiply it by 4. And we're going to add that to current address. And that's going to be the too far address. Well, since the too far address is a register in itself, we don't need to accumulate this in RAX any longer. We can do all this directly. We don't need to move that at the end. We should just have that in there. Now the loop will be about the same. We're going to subtract that from that. Jump will be the same. I'm going to do this a little differently. So we want to zero out the contents in memory. So there's a way to do that. Sometimes you gotta, when you don't have a register, okay, that DD there, that needs to be there. It's a specifier to specify 4 bytes of memory that we're going to do. You need that when you're not using a register, which I won't be using a register. I'm going to be using, okay, I lied. I am using a register called current address, but what's in those brackets, it doesn't specify size, it just specifies location. And I'm going to be using the immediate 0. So the DD is required to force the size of memory to be 4 bytes. So that will put 0 into memory at the current address. So we won't need to do this, we won't need to do this, but we do need to increment our loop, add 4 bytes on, and we do need to jump up. And I'm going to call that zero out array. Let's go up here, so we're going to print array, and I believe then he goes invoke zero out array, my array, and then he's going to go invoke print my array. I believe that's what we're going to do. Let's give that a shot. Whoa. Okay, it worked. So there's our 8675. We zeroed it out, and then we reprinted it. We have 0000. Okay. I do want to go one step further here, and point something out here. That since I have quantity and quantity used, there's kind of a different a couple different things you can do with this. For example, one thing you could do, let's say instead of zeroing out the array, you could just say move my array dot quantity used, comma 0. What's that going to do? So we got 8675 and then array, nothing. What happened? Well, it basically thinks the array has a 0 quantity, so it didn't print anything out. But the values are still in there, which is kind of handy. It's kind of like, well, the array is, the data's still there, but you know, we're not looking at it anymore. I want to give a little better visualization of what's going on here. So I'm in the debugger right now at the point in time where the array has been printed, and the address 32180 is the address of our data, address pointed at. And I have that down here in the lower dump 32180. You gotta kind of look down here, down here. And you see the 8675. There's our 4 numbers in our array. There's our data for the array, literally. If I go backwards one more row, and I see the line 32170, you're going to see an 8-byte value 5 and an 8-byte value 4. That's literally where quantity and quantity used is located. 4. It's literally just tucked in and stored before the array data. So what I'm going to do now is I'm going to execute the line that we're on, which is right here. And we're going to move the value 0 into the address 32178, which is right where that 4 is at. 32178. So when I hit F8 on the keyboard, you see that that's 0 now. It's literally the property quantity used has now been turned into 0. Now I go into this function, which will zero out the array, and it, sorry, it didn't zero out the array, it printed the array. My bad. And it didn't print anything out because quantity used is 0. So the data is still there, though. Just we don't think the array exists at that point. So that's kind of what's going on here. It's just a little different. Not worse than, not better than, just a little different. Okay, at this time, stop this video and watch the other video up to the point of 1334. And then come back to this video. Okay, we're going to make the function called printIt. And I'm going to put that right here. What we're going to do is I'm going to make a variable called element. By the way, the named is optional. This passes by value, by the way. So because, again, my console.code.writeLine, my overloading, I'm just going to put this front here. It only understands DQs. Again, I don't have overloading for DDs. I need a DQ. So I'm going to build RX for what I need. And again, I want to make sure RX is zeroed out. I'm going to move into EAX element. That'll be my printIt function. Now we come up here let's comment out a few things. And invoke print it 99. Now, okay, one other little thing. My print it's, my console write line prints numbers in hex by default. I do have a way of overriding that with this optional parameter called number format. I believe I can access the enum by typing the module name dot enums dot number format dot decimal. You can see how the IntelliSense just walks you through that, helps you type that in. So yeah, let's, before we compile around that, let's do the entire step. So now we want to print out the third element of the array, which is the 7. Well, I don't have the syntax that C++ has, so I'm kind of stuck a little bit. But and there's like I said, more than one way to skin a cat. But what I'm going to do today is I'm going to create another local variable. It's going to be a DD variable. This one's going to be a pointer. So I do have pointer support, and I'm going to call it my DD. I'm going to move into my DD dot address pointed at an address. Well, what is the address that I want to move into my pointer? Well, I'll use the load effective address instruction, and I'm going to do myArray dot address plus, let's say 4 times index. This is kind of backwards programming because index doesn't exist. So let's make a local register x8 named index. I don't know if you can hear this microphone. I have a cat fight going outside. Now it's got the puppy excited. Let me pause the video and chase the cats off. I'll be back in a second. Well, I just so I accidentally let the dog out, and then the dog found the cats. And then they ran the Mogadishu Mile, and then when he gave up, or she gave up, she came back. So we're all back. Yeah, you're good. You got him, didn't you, puppy? Yeah. Them nasty cats. Them dang dirty cats. Okay, so where was I? Let's see, where was I? Print 99. Okay. Oh yeah, index doesn't exist. There's a variable register named index. All right. Move into index 2. All right, so so if I want the third element, I have to add 8 to the base address, because adding 0 is okay. You kind of got to. We'll just, hey, let's run it and see what we get. How's that sound? Load that in REX, move that into the pointer. Oh yeah, we have to make sure we call invoke print it. And we're going to do my mydd. So this compiler will accept the mydd pointer and do whatever magic it needs to do in the background to make it all work. Hopefully. Let's compile this, see what we got. There it is. In decimal format. Element 99 and element 7. Fantastic. Okay, at this time you can watch the rest of the video and then come back. Okay, now that you're back, you've seen the rest of the video. Last function that he makes is called change it. And it's a DD, I'm going to call it var1 and new value. So what we said earlier is that these variables pass by value, and the change it requires it to pass by reference. So we will change that in a second, but I just want to show you the difference. In order to make this assignment, I'm going to type it in like this. var1 dot. See how my options are address and size? It's because the address will be an address on the stack, which is the value that has been copied on the stack. So this this will just change the stack variable, which is not what we want. We want to change the original variable. So in order to make this variable pass by reference, I need to add the byref keyword. And what that does is it changes things a little bit. So now when I do my IntelliSense, I see that I have the address pointed at property because var1 is now a pointer to the original data. Address pointed at. And the data we're going to use is new value. Notice that I'm not typing DD here. I could. It's optional. It's because the compiler knows new value is a DD, and that's what dictates the size of the instruction. So there's our change it function. Let's see. Let's comment out that. Let's go up here. Let's see, what did he do? So he made it variable x. Let's just do the same thing. Local dd x. Initialize it. I don't know, what was it? 3. Let me go look real quick. Okay, I had to go back. So x starts out as 9. Let's go down here and we're going to invoke change it on x equals 3. And then we're going to invoke print it on x. I got some red letters here. Local. There. Let's just, I could comment that out, but let's just jump over it for a minute so we can see what this does. We'll do this in 2 steps. So there is element 3. Boom. Started out as 9, run change it, became a 3. Now I'm going to comment that out. Take out that jump. Take out the indentions. And The next step is to change element 2 to 3, I believe. Let me go look again. Okay, I had to go back and relook at the video again. Element 2, it's really element 3, which is index 2. And we're going to change that element of the array to the value 3. There we go. I think I said it right. So we're going to use this code a little bit. We're going to use that pointer again. So again, it's index 2. There's the address of index 2. And we're going to move, set the pointer up. And I don't think we want to print it. We want to invoke change it of my array. No. My DB to be 3. And then we're gonna print my array. Let's give that a shot. Voila! You see the original array, the third element was a 7, now it's a 3, and that's what the professor did in his video. And there we have it. So, hope you enjoyed this a little bit. And I don't know if you got more of a better opinion about assembly or a worse opinion. It's a little different, but in a lot of ways it's the same. A lot of things are very similar. The syntax, to me, isn't so bad. I do like the fact that I have the quantity and quantity used. It opens up kind of gives you more possibilities of what you can do. So I kind of personally like that. But anyway, thanks for watching.